This is the first lesson in the Year 13 A-Level Maths course on the pure and mechanics side. And what this lesson is going to look at is it's going to tell you all about a different measure that we use for angles called radians. Now you'll find these are very useful and essential for some of the work that you do to do with trig ratios and measuring angles in Year 13. So let's have a look at the series of lessons that we're going to be doing. So today is the bit in red, so we're going to look at what the link is between degrees, which you're obviously already familiar with, but the link between degrees and radians. We'll need to be able to switch between degrees and radians, have a look at drawing trig graphs in radians, transformations of those graphs, and then have a look also at angles that are measured in radians. We already know some exact values for angles like sine of 30 and cos of 45 and that sort of thing. So we're going to look at the equivalent measures in radians. Then what we're going to go on to is to do with finding arc lengths and areas of sectors and segments, which you will have already done when we've got the angle measured in degrees, but we're going to do that where it's measured in radians, and actually it makes them a lot easier. We're going to solve trig functions in radians, so solve equations that have trig functions in them, but look at answers in radians. So again, you're going to be applying your knowledge that you already have for solving in degrees and do the same thing, but just our answers are going to be working in radians mode. And then a little extra at the end is approximate trig values when theta is small. Okay, so let's have a look first of all at what the radian measure is all about. If you think about measuring things in degrees, which you've been very, very used to doing when you measure angles since you've been quite small. Now, how degrees are worked out is you take a full turn, or you take a circle and you split it into 360 equal parts, and each of those is called a degree. Now it seems a little bit random using 360. The reason back in the olden days that they chose 360 is because it has a lot of numbers that divide exactly into it, so it was quite a useful number to split our circle into. But if you think about the problem with degrees is when we're using it in an equation, so maybe you're solving an equation that has sine x and x in it. If we're measuring x in degrees, say x is 60 degrees, sine of 60, that's fine, I can do that. But you imagine then that you're going to have x just as a value in that equation. Suddenly to do sine x plus x, where x is equal to 60, doesn't seem to make sense, because the only reason it's 60 in terms of degrees is that it's 60 out of 360. So introducing a different measure called radians enables the measure to actually have some link to a physical length measurement, which is going to be useful when we do things like calculus to do with trig functions. So that's differentiation and integration. So let's have a look at what a radian is all about. Okay. So radian actually has a bit of a length associated with it. So this is the sort of, official description of it. If you say 1 radian, if you wanted to draw 1 radian, then what you would do is you would draw a circle and you would mark off a sector there. And as soon as the arc length is the same length as the radius, so in posh words, it says the angle subtended at the centre of a circle by an arc whose length is equal to the radius. But as soon as this length here, which is your arc length, as soon as that has the same length as the radius, then that defines 1 radian. Okay. Now, just a little bit of sort of notation. You'll find in the textbook that they tend to write 1 radian as 1 rad. Now, the notation I prefer to use is 1 radian. You put a little c at the top there for 1 radian. Okay, so that's a radian. Okay, in the same way as this is degrees. So you can use either. You can write rad, or you can write just a little c at the top there. Okay. Now, a little side from this definition here is saying that if we've got the angle here, okay, as theta, so the angle at the centre there is theta, then the angle theta is basically the length of the arc divided by the radius. Now, more of that will come into when we're actually going to be calculating arc lengths and areas of sectors, but that's just something useful to remember. So what I'd suggest you make sure you've got written down, make sure you've got written down this. I would draw that diagram. I would also make sure you know about this notation, a little C at the top, and then write this bit down as well. So if you need to pause it to write that down, then please do. Okay, let's go on then. So we need somehow to be able to link a radian with degrees so that we have an idea of converting between them. So if we remember, okay, what we'd said before, if I was to make the angle at the centre of the little sector here, if I was to make that all the way round, then the angle would be 2 pi, because my whole circumference of my circle is a whole arc of length 2 pi r. Remember that from your formula, or it's pi d, isn't it? But that's the same as 2 pi r. So what that tells you is, from the definition of a radian, that the angle that it subtends at the centre of the circle is actually 2 pi radians. Okay, so what that does is that gives us a link between radians and degrees, because we know a full turn or a full circle is 360 degrees. So this gives us this link between radians and degrees. So 2 pi radians is equal to 360 degrees. The reason being, a full turn gives you the whole circumference all the way around as the arc length. The whole circumference is 2 pi r, but the radius is r, so that gives you 2 pi in this full circle turn here. Okay, now this is the one that I always remember. Okay, so this is what ultimately ties me back between radians and degrees. Okay, 2 pi radians is 360, but I always remember that pi radians is equal to 180 degrees. Okay, so you've got to remember that. That's not given to you, that's not specified anywhere. So you've got to remember that pi radians is 180 degrees. Okay, and from that, if you remember that, you'll get this fact here as well. So that tells you that 1 radian is 180 over pi. So you've got to find a way of remembering that. All right, and the one I remember is pi radians is 180 degrees. So that's important to make sure you've got that written down. Okay, right, so what we're going to do next is we're going to do a little bit of converting between degrees and radians. Now, in a moment, I will show you how you can work your calculator in radians to work things out, but we're going to do these manually, okay, converting between radians and degrees. So let's have a look at a few examples there. Okay, so what you'll notice here is, for part A, this angle here, so let's call it theta, is 7 pi over 8. Now, how you'll hear me saying that, if I specify as an answer, for example, is 7 pi by 8. Now, notice here, they've put rad there. If you were giving that as an answer to a question, you would not need to write rad, you would not need to do the little c either. Reason being, anything that has a pi in it, then by default, it is assumed that if it's got a pi in it, then it's going to be to do with radians, because radians is to do with pi. It wouldn't make sense to have a number of degrees in terms of pi. Okay, right, so what we're going to do to convert that to degrees is we're going to use this fact here, that 1 radian is 180 divided by pi. So if I take that and times it by 180 divided by pi, okay, then that's going to give me my number of degrees. All right, you'll see what happens there. The pi's cancel, so it's 7/8 of 180. Okay, so remember, 1 radian, or pi radians is 180 degrees. So another way you can think of it is you can think, okay, well, I'll just ignore that pi and I'll do 7/8 of 180. That's quite often how I think about it when I'm doing these. It's 7/8 of 180. Okay, that's not a particularly nice number, all right, so you put that in your calculator, comes out as 148.7. That can't be right. 7/8 of 180. Oh yes, it is. So 148.75. We put a little circle because that is degrees. Okay, so 148.75 degrees. Okay, let's do part B then. Okay, so here we've got 4 pi by 15. Okay, so you can think of it as 4/15 of 180, or you can do your times 180 over pi and actually physically see those pi's cancel. Again, pop that in your calculator. All of the exams you do in maths will be calculator based. Make sure you write your working down though. So 4/15 of 180 is 48 degrees. Okay, so you can sort of start to see what the size of the angles are that relate to each other. Okay, that's some of the difficulty that you will find when you start using radians, especially if you've got to, for example, put an angle on a cast diagram or on a graph, is actually thinking how big is that particular angle. You're very used to, in degrees, knowing how big a 50-degree angle is, but at the moment you are not very used to thinking how big is 4 pi over 15. Okay, but if you do try and remember, it's always the fraction of 180, then that can help you, because if you look at part A, 7/8, well, that's almost 1 whole one, so that would be quite close to a straight line. You can see the 148.75 there, so that can help you just to think about the size of it, but you'll get more used to them the more you do with them. Okay, right, let's go the other way around then. So convert the following angles into radians. Now, quite often with angles in radians, you will leave them in terms of pi, all right? And your calculator will give you, you know, so will enable you to put things in terms of pi. Okay, so 150. Okay, so remember what we want to know is pi radians is 180 degrees. So we want to know what fraction, okay, of 180 is 150. Okay, so what you do, you can times by pi on the top, gives you the pi in the answer, divided by 180, and if I simplify that, I get, we call 5 pi by 6. Now, notice here, you don't need to say rad, and you don't need to say the little c. They aren't needed because there's a pi in the answer, and a pi in the answer will by default say that that is radians. Okay, 110. Okay, again that's less than 180, so it's going to be a fraction of pi. So times it by pi over 180. Use your calculator to help you cancel that down, and you get 11 pi over 18. Again, no rad or little c needed. Okay, because it's got the pi in the answer. Now, you will come across quite a lot of sort of standard angles that you may be working with, so it is useful, I think, for you to remember, especially some of these common ones. You already know about 180, you already know about 360, so let's have a look at some of the other more common ones that we come across, write them down, and hopefully we'll start to remember them. Okay. So if you do need to pause to have some time to copy these down, please do. All right, so what we're going to do is fill in the gaps here, okay, with what these degrees are when they're written as radians. Okay, 180 degrees pi, we know that. That's the one you're going to remember. That's always the go back to point that you're going to remember. 360, 2 pi, 1 radian, pi over 180. Okay, now these ones here, you should really remember what these are. Okay, if you remember that 180 is pi, 90 is half of 180, so that's pi by 2. That's how you say that, pi by 2. Okay, then again, 45, that's a common one that comes up. 45 is a quarter of 180, so you read that as pi by 4. Okay, 45 degrees, pi by 4. 30, so 30 degrees is a sixth of 180, so pi by 6. Okay, and 60 degrees is a third of 180, so again, pi by 3. Okay, so all of the ones in this side here, you should try and remember those. You will get used to them the more of them you do. If you ever forget what they are, it's very easy. You can just do 60, for example, times pi over 180. And you can see that gives you the pi by 3. So if you do forget, you can always revert back to there. Okay, right, let's have a look at these. Some of these we might be able to just look at and do. Some of them might take a little bit more work. Now 120, well 120 is double 60. So I reckon we can straight away say, well that's 2 lots of 60, so that's 2 pi by 3. Again, if you weren't sure, do 120 times pi over 180 and cancel it down. Okay, 135. Okay, well 135 is 3 lots of 45. Okay, so that's going to be 3 pi by 4. I might not necessarily remember that, so just do 135 times pi over 180. Stick that in your calculator and you'll notice when you do 135 over 180 you get 3/4. Okay, 150. Okay, well 150 is 5 lots of 30, so that's going to give us our 5 pi by 6. But again, if you're not sure, 150 times pi over 180 will get you there. Okay, 210. Okay, well that's going to be 7 lots of 30, so that's going to give us our 7 pi by 6. So notice that's a top heavy fraction. You'd expect that because that is more than 180. So it's going to be more than 1 lot of pi. Okay, so it's going to be a top heavy fraction. 270, well that's 3 lots of 90, so that's going to be 3 pi by 2. Again, notice top heavy fraction because it's bigger than 180. 300, okay, well that's 5 lots of 60, so that's going to give you 5 pi by 3. But if you don't remember, 300 times pi over 180 will get you exactly the same answer. And 315, okay, well that's 7 lots of 45, so that's 7 pi by 4. I might not remember that one, so that might require me to go 315 divided by 180. So if I was doing that in my calculator, I probably wouldn't even put the pi in. I'd probably do 315 over 180. That would give me the fraction, stick a pi at the end. All right, so make sure you've got those all written down and make sure you're nice and happy with how to work those out. Okay, right, what we're going to go on to now then is using our calculator. Now you may well, perhaps in your GCSE exam, you may well have accidentally ended up in Radians mode in your calculator and it starts giving you some funny answers. That's the reason why, because you have to put the angle into your calculator in radians. Now, how you know which mode it's in? At the top of your calculator, at the moment it probably has got a D in the top bar with a black box around it. That means you're in degrees mode. You want to put it in radians mode. Okay, so here's the things you do. You press Shift, you press Menu, and you'll see it comes up with some options there. You press option number 2, which is angle unit. Okay, press option 2 and you select option 2, which is radians. Okay, so once you've done that, notice at the top there you've got an R with a black box around it. That tells you you are in radians mode. Now in your A-level maths exam, you will need to be able to change between radians and degrees depending on what the question is asking you to work in. So you have to remember, you do Shift, Menu, option 2, and then you choose 1 for degrees and 2 for radians. Okay, let's make sure you're in the right mode then. Okay, what you'll find is if you turn your calculator off, then it just comes back to the same mode. Okay, so type into your calculator sine of 0.3. Sine 0.3. If you're in radians mode, you should get 0.295520267. Read the question, 2 decimal places, so 0.30. Do put the 0 on the end because it's asked it for 2 decimal places, not 1. So you need a 0. Right, the next one, cos of pi. Now, I wouldn't expect the question to have rad written there. I would just expect it to see cos of pi. So cos, when you type in pi, use the pi button. That's shift and the times 10 to the x. Okay, pi is 180. So if you remember what the graph goes like, okay, if you do cos of 180, you get -1, and that's what comes up. And the last one, tan of 2 radians. Okay, so you type in tan, you type in 2, you type in equals, and you round it, -2.19, round carefully to 2 decimal places. Okay, so we're in radians mode, and that's what our calculator is telling us. Okay, next then, we're just going to draw a couple of graphs, but with radians as our angle measure. So let's have a look at doing that. Here's our first one. So write that one down. Sketch the graph of y equals sine x for between 0 and 2 pi. Okay, you don't tend to you always tend to, when you're working in radians, sort of translate them back to what that means in terms of degrees, just because you're so familiar with degrees. So that's saying sketch a sine graph between 0 and 360. So off you go, draw your axes. You don't need negative x-axes, just need positive x-axes. If you forget, you can always use it to use your calculator to work out some values. You should know sine of 0, 0, and then it's the wavy graph like that. Okay, so your y-axis, your x-axis, mark some important things on your x-axis. For example, it goes through at pi. Okay, the peak there is at pi by 2, which is 90. And then the -1 is 3 pi by 2 and then 2 pi. So that's going to be good for that one. Okay, so make sure you sketch that. Please use a pencil and a ruler for your axes though. Next one, that was a nice easy one. Sketch the graph of y equals cos x plus pi between, again, 0 and 2 pi, so between 0 and 360. Now we're going to use graph transformations for this. So if you have a look at that, think back to your graph transformations. If you replace x with x plus pi, you're replacing x with something. Okay, so it's going to be changing things in the x direction. So this, you should remember, is a translation. There's some of these on the questions you're doing. So do refer back to year 12 notes for your graph transformations if you need to. So a translation, okay, in the x direction. And remember, anything you do in the x direction is always the opposite or a bit different to what you think by minus pi. Okay, so it takes my graph of what my normal cos graph would look like, and it shifts it by minus pi, which is 180. Okay, so you have a go at drawing that and think about what it looks like. Pause it if you need to. Let me show you what it looks like. Now the dash graph here is your normal cos graph. It goes through at 1. So if I shift it, okay, by minus pi, then I've basically moved it so that the point that is at 1, okay, is going to be shifted along by pi. So the graph is now going to look like that. If you're not sure, then just try a few values in your calculator and that will help you. Okay, so you should see at pi, okay, that gives us our maximum value here for pi. Okay. And at 0, that's going to be cos of pi, which is -1, and it does that up and down shape like that. So do make sure you've got that sketched down and you're happy with that. Okay, you remember back in GCSE, you had some exact values that in GCSE they wanted you to learn those and remember them, basically because there is one GCSE paper that has no calculator. Now, although this says to sort of, learn these. I don't think you need to learn these because you can put them in your calculator and it will tell you. The only thing you'll need to remember really is how 30 degrees is the same as pi by 6, 60 degrees pi by 3, 45 degrees is pi by 4. Okay, so if you want to work these out, then you can just put them in your calculator. Why don't you practice putting in a couple into your calculator? So if you're in Radians mode and you type in sine, I would probably use my fraction button, type in a pi on the top, type in a 6 on the bottom, and you should get a half. Okay, so write these ones down because we will be making use of them. Cos pi by 6, that gives you √3 over 2. Remember how you could prove these in GCSE? You used to draw the little triangles, didn't you? Okay, tan 1 over √3, sine √3 over 2, sine 60, cos 60, a half, tan 60, just √3, sine 45, cos 45, both the same. Okay, your calculator, if you type these in, will actually give these in rationalised form, so that will give that as √2 over 2, but it's the same. And tan 45, that's your isosceles triangle, that's 1. Okay, so you don't need to learn those. Okay, you can remember, you can get those from typing them into your calculator. Okay, so what we're going to do for our final bit here is, in reality, I guess they wouldn't expect you to do these without using a calculator. They would just expect you to type them in. But this is going to give us just a little bit of practice of using those cast diagrams again that you've already used to work out values for solving trig equations. Now, you'll end up using these quite a lot in year 13, so I think they're really good ones for you to get to grips with. So let's just do a couple of questions on those, and we're not going to use our calculators for these. Okay, so without a calculator, let's have a look at how we could work out cos of 4 pi by 3. Now, what we can do is we can draw that onto a cast diagram. So quick reminder of cast diagrams. This, remember, is your 0. This here would be 90. Do you remember what 90 is in radians? Pi by 2. And round to here in radians, this would be pi, which is 180. So if I was to draw 4 pi by 3 on here, now that's more than pi, isn't it? Because pi is 3 pi by 3. So it's going to be somewhere down there, okay, where this angle here is pi by 3 and 4 pi by 3, if I just show you in red, 4 pi by 3, it's all the way around there. That's your 4 pi by 3. Okay, remember how your cast diagrams work. You label them C, A, S, T. What those letters tell you is which trig ratios are positive in that quadrant. So we are in this quadrant for 4 pi by 3. Tan is positive there, so cos isn't positive. So the equivalent angle that you read, remember, is always the one that you've read relative to this big, long horizontal line here. So cos 4 pi by 3 is going to have the same value as cos of pi by 3, but because it's in that quadrant, it's going to have a minus sign in front of it. So this is what they want you to do for these questions, okay, is they want you to draw your cast diagram, they want you to work out the quadrant, and they want you to work out what is the corresponding common value that we did on the last table. Okay, so it's going to be minus whatever the value of cos pi by 3 is, refer back to your table, and that's going to give you minus a half. And if you want to check that you're right, that you've done your cast diagrams right, type that into your calculator and it will indeed tell you that it is minus a half. But it's important you understand what we're doing here, because we're going to be doing some of these when we solve trig equations to get subsequent values, okay, when we're working in radians. Let's do this second one then before it's over to you. Cos minus 7 pi by 6. Cast diagram again. Okay, now let's draw this on our cast diagram. remember, when we're doing a negative angle, we start here and we go round that way. That is negative. 7 pi by 6, 7 pi by 6 is more than 180, so we're going to go all the way round. Okay, we're going to go all the way round there and up to this point here. Okay, so 7 pi by 6 is starting here, it's going minus pi minus 7 pi by 6. So this angle here is going to be a pi by 6. Okay, so can you all understand and see where that's come from? Negative because it goes around this way. 7 pi by 6 is pi and then a little bit more. Let's do our cast diagram. C, A, S, T. Now the quadrant we're in is this one. So sine is actually positive in that quadrant. So this is going to have the same value as sine of pi by 6. Remember, it's always relative to this horizontal line here. It's going to have the same value as that, but it's going to be a plus, okay, because it's in that quadrant. This one is one of the ones on our table on the previous page, so that's equal to a half. And again, you can type that in your calculator. You can type this in, all right, just to make sure that it does indeed give you that value, and it does. But it's you understanding where that's come from. Okay, so that's introduction to radians. Here's your questions. Looks like quite a lot, but they're quite small questions. Okay, do write out the question first. Okay, do read the question carefully for specified accuracy. Some of you fall foul sometimes if they say to 3 decimal places. If you don't give it to 3 decimal places, then you will lose a mark for that. Okay, so sorry, excuse me. So exercise 5A, those questions, and exercise 5B, those questions. Just pause this if you need to write them down. Okay, no submitting of this work. All right, we'll be asking for some of the other work to be submitted, but just not this one. Okay, right, I hope that's all clear. If there's anything you're not sure about, then please do go back and review the video again. Okay, thank you.